It's Neha again, and welcome back to NeetCode Easy. Today we are solving problem 6, Encode and Decode Strings. Let's read the problem to make sure we don't miss any information. Design an algorithm to encode a list of strings to a single string. The encoded string is then decoded back to the original list of strings. So in this problem, we'll build two functions, encode, which takes a list of strings and returns a single encoded string, and decode, which takes that encoded string and reconstructs the original list. As we can see, example 1 has list of strings as input and the output is the same list. Because what we are doing here is we are simply encoding and then decoding back to the original list. Before we start solving the problem, let's also consider constraints and efficiency. So here, the number of strings is between 1 and 200. Each string is made of UTF-8 characters, and it can be up to 1000 characters long. So we don't have to deal with any tricky edge cases here. Also, the problem encourages us to aim for a solution with time complexity big O of m for encode and decode, and space complexity big O of m plus n, where m is the sum of lengths of all strings and n is the number of strings. Now let's start with the encoding. At first, you might think of joining all the strings together using a delimiter. For example, given a list of strings like so let's say we have this input. We could simply encode it using #, the delimiter, and it will look something like this. This is easy, simple, and this works fine when strings don't have delimiters. However, what if one of the strings already contains a delimiter, let's say a #? For instance, if the input is something like this, so as you can see, our input string has delimiter #, and it's a part of this string. Things can get messy here because we cannot distinguish between the delimiter and the characters within the strings. So to solve this, a better approach is to store the length of each string somewhere, and the best place to store the size is simply before string itself. We simply prefix each string with its length followed by the delimiter. For example, let's take this input again. So the encoded string will be first the length of the string, which is 4 here, followed by delimiter, and then the string itself. We'll do the same for the rest of the strings. This way we always know exactly how many characters to read for each word, no matter what characters the string contains. Let's start writing the code. I'll just comment this out. We will start with initializing an empty string, and we'll name it encode. And what we will do here is we'll loop through the string in the list. So for s in STRS, we'll first take the length of the string. We'll use length function here, and then add #, and then the string itself. But here, the length function will give integer output. We need to convert it in string. And finally, what we will do here is we will append this value to the encode. So encode plus equals this. And finally, we'll return the encode. This code is so simple, and this way, when we decode, we can easily determine where each string starts and ends, and we will know the length of each string in advance. And here our first half of this problem is solved. Now let's think about decoding. So the input here is the encoded string which only contains UTF-8 characters. Something like this one, or this one. So our strategy will be, we start by reading the string until we hit the delimiter. The number before this delimiter tells us the length of the next word. For example, as you can see here, before the delimiter we have number 4. So we know next string will have 4 characters. And once we have extracted our first word, we move forward and repeat the process for the rest of the string. But here's the catch. How do we remember where we left off after each word? And that's where a pointer comes in. Let's call it I. So pointer keeps track of our position in the encoded string. Without this, we would keep going back to the beginning and reading the same part over and over. This pointer helps us move efficiently through the string, grabbing one word at a time until we have decoded the full list. Let's start writing our code. We will first need an empty list to store all the results. And then we'll start a for loop to continue until we reach the end of each string. So while I less than length of each string, what we will do here is we will initiate another pointer to find the position of each delimiter. So j will assign the value I, and then inside this loop we will need another loop to move j forward until we find the delimiter. While s of j is not equals pound. Until we find the pound sign, keep incrementing j by 1. This is what we mean here. And then what we will do here is, once we found the delimiter, the number before the delimiter will be the size of the string. So we go pointer position I to j. J we will not include j here. We will stop before j. So s from I to j. This value will be string, so we need integer value. For that, we will convert it into integer and store it in variable called length. And now what we will do here is, once we found the length of our next string, we will extract the string from s starting just after the delimiter j plus 1. And then we will append this decoded string to the decoded list. So decode dot append, we will take s starting with j plus 1, moving up to j plus 1 plus length, and then we will append it to the decode. Now once we found our first string, we will move the pointer forward to start of the next string. So I will be simply j plus 1 plus the length variable here. And finally, we will return the decode. And this is how our code look like. Let's run this and check if our code passes all test cases. We have an error here, so let's try debugging it. Everything looks good here. Let me check one more time. Okay, so the return function, the return value will be outside the while loop. Let me try it again. And as you can see, all the test cases are passed. So we finally solved this problem. So what we have done here is we first started with reading from the beginning of the string, and then we kept reading until we find a delimiter. The number before it tells how long the next word will be. After the delimiter, we grab that many characters to get one of the original words. And then we moved forward and repeated the process. We did this until we reached the end of the string, and finally, we returned the list of the decoded strings. Now, if we check the efficiency here, for both encode and decode, we only went through the string once. So the time complexity will be big O of m. Also, we built an output string or list of strings along the way, so the space complexity is big O of m plus n. And that's our problem 6 solved. In the next video, we will solve problem 7, products of array. I'll see you in the next one. Bye-bye.